Alright, today we'll talk about general and specific solutions. So suppose you have y prime minus xy equal to 0. You could solve this, and you'll probably get y equals to e to the 1/2 x squared times c as a solution. Actually, I didn't really solve it as a separable equation because, I mean, you could solve this as a separable equation. You can move this to the other side, divide by y, and then try some methods to solve this. But in my mind, it's just that if I differentiate this function, the inside function has to be pulled out, and you differentiate the inside function, what do you get? You get x, right? So I can see that this is an example of such a function that satisfies that. Okay? And not only that, I know that any multiple of this will still satisfy this equation because the derivative will preserve this constant, and it's just y itself, so it seems like this should be fine. Now, but let's turn the tables. What if you are given the solution and somebody told you, hey, I think this is the answer, okay? And you don't really want to solve it? How would you check? To check this solution, you would differentiate and plug them in, right? So to check, first differentiate it. Y prime, using the chain rule, e to the x differentiates to e to the x, but that inside function has to be pulled out and differentiated. And 2 comes down. 2 times 1/2 is 1, so you have x. So you have c times e to the 1/2 x squared times x. That's your y prime. Therefore, I can replace y prime by that. So now this equation now becomes c times e to the 1/2 x squared times x minus x times, what's y? Y is this much, right? C times e to the 1/2 x squared. And if you subtract them, what do you get? They're exactly the same, right? So the left side just becomes 0, which is the right side. Therefore, you've shown that by differentiating and just plugging in, you've shown that this is a solution. Okay, so just check, it's a solution. Right. And because this has C in there, you call this a general solution. So maybe I should write it as y equals to c times e to the 1/2 x squared is called a general solution to y prime minus xy equals to 0. Okay? Now, however, sometimes you want to solve a differential equation with a given initial condition, right? So what if you had an initial condition that y of 0 is 3? Now in that case, this is not going to satisfy both of them. This is only going to satisfy this one. So in order to satisfy this, along with y of 0 equals to 3, you have to solve for c, right? So y of 0 equals to 3 implies that 3 is equal to, since y of 0 is this thing with x replaced by 0, we get 3 equals to c times e to the 0th power. What's e to the 0th power? 1. And therefore c is equals to 3, and that implies that y is equal to 3 times e to the 1/2 x squared. And then we say this is the specific solution.
Doctor?
Yes.
Isn't that just that form is first order linear, right?
Oh, okay. So this one is both first order linear and also separable. You can solve it as a separable differential equation, and you can also solve it as a first order linear.
So general is when it still has c in it, and specific is when it has the value for c in it?
Yes.
Okay.
Yes. General means your parameters is not determined. Specific is when all the parameters are determined, and you have not only satisfied the differential equation, but also the initial condition. This initial condition here is also specified.